So let's just move on further and talk about the last concept of the coordinate geometry, which is nothing but called as the area of a triangle. Now we already are aware about how we can find the area of a triangle using the formula having the base and height as nothing but area of triangle, which is equal to half into base into height. So using this formula, if base and height of any particular triangle is given, then we can find the area of the triangle. And moreover, we already are done with the concept of the Heron's formula, that using the Heron's formula we can also find the area of the triangle. But let us suppose if the coordinates of the vertices of a triangle is given to us, then how we can find the area of the triangle. So we will learn about this particular concept in this area of triangle concept. So let's just talk about how we can find the area of a particular triangle whose coordinates of the vertices are given to us. So let us suppose we have our xy particular axes and we have the three points, or we can say that we have the coordinates of the vertices of the triangle, which is given to us as nothing but x1 y1 as x2 y2 and x3 y3. Now we just wanted to find out the area of the triangle ABC. So how we can find it? Let's just talk about finding out the area, but before that we have to do a little bit of construction. And what is that? Let us suppose if I'm drawing a perpendicular from all these vertices, from B, from A, from C on the x-axis. So let us suppose if I'm drawing a perpendicular from the vertex B as BQ on the x-axis, similarly from A as AP perpendicular, which is on the x-axis, and similarly from the point C as well. So I'm drawing again a perpendicular CR, which is on the x-axis. So as we can see, we have three trapeziums over here. We have three trapeziums. What are those? Let us suppose if I'm talking about the very first trapezium, which is A, B, Q, P. This is a trapezium. Furthermore, we have again this as a trapezium, which is A, P, R, C. Furthermore, we have another trapezium, that is the third trapezium, which is B, Q, R, C. So using these three trapezium, we will find the area of this particular triangle. So let's just write how we can find the area of the triangle using these three trapeziums. So area of the triangle ABC is equal to the area of trapezium, ABQP plus the area of trapezium the trapezium is APRC minus of the area of trapezium which is BQRC. Now you can see if we'll add the areas of these two trapeziums, and we will subtract the area of this trapezium, then we will get a region which is nothing under the area of the triangle, that is ABC. So only this portion will be left out if we'll add the area of these two trapezium and subtract the area of this trapezium. So hence area of the triangle ABC is equal to the area of the trapezium ABQP plus the area of the trapezium APRC minus the area of the trapezium BQRC. So let's just find out the area of the triangle using the area of trapezium. But before that, we do know about the formula for the area of trapezium. So the area of trapezium is equal to half into sum of parallel sides, into the distance between them, So I'm not just writing distance between them, so I'm only writing the distance. So the distance between them. So let's just talk about first of all the area of the trapezium ABQP. and P. So let us suppose if I am writing the area of the trapezium, so this would be nothing but is equal to, half into sum of parallel sides. So as you can see, the sum of parallel sides is nothing but BQ and AP. These are the parallel sides of this particular trapezium. So this would be BP plus of AP into the distance between them. So the distance in between them is nothing but this QP. As you can see, this QP is nothing but the distance in between these two parallel lines. So this will be into QP. Let's move on further. Plus half of the trapezium, plus half of we are talking about the trapezium ARPC. So let's just talk about AR or APRC. So first of all, the parallel sides are nothing but AP and CR. So this is nothing but half into AP plus of CR into the distance between them. So the distance between both of these is nothing but PR. So this is PR. Further, minus half of the area of the trapezium. We are talking about the area of trapezium of BQRC. So again, BQRC. So the parallel sides are BQ and CR. So this is half of BQ plus CR. And further we have the distance in between both of these as nothing but QR. This is QR. So let's just substitute the values of BP, AP, QP, AP, CR and each and everything. So let us suppose if I'm starting with taking the values, as we know that B do have a coordinate as x1, y1. It means that the distance of this particular point Q from the origin is nothing but x2. This is nothing but x2 because the coordinates are x2. The coordinates are x2, y2. So this is nothing but x2. Again, if we are talking about BQ, so its distance actually, or we can say BQ is nothing but y2. This is nothing but y2. So this distance is actually y2. Now let's just talk about further. As we can see, we have the coordinates of A as x1, y1. It means that the P is at the point x1 distance from the origin. So it means the distance of the point P from the origin is nothing but x1. So this is in total x1. So if this is x1, this is x2, then this particular distance is definitely x1 minus x2. So this is x1 minus x2. Further, let us suppose if we are moving towards this particular A, so we can see that this particular distance is nothing but y1. This distance is nothing but in total. This is nothing but y1. And similarly, if we just move further, as you can see, we have C's coordinate as x3, y3. It means R is at a distance of x3 from the origin. So this whole distance is nothing but x3. This is x3. So it means that if this is x3, this is x1, so PR is nothing but in total a distance that is x3 minus x1. This is x3 minus of x1. And again the CR total distance is nothing but y3. This is a y3. So let's just plug in all the values. Over here. So first of all, we'll start with substituting the values of BP. So first of all, BP, what is the value of P we have? Sorry, it is not BP. As you can see, these are the parallel lines, that is BQ and AP. So this is actually BQ. So what is the value of BQ? BQ is nothing but y2 and plus of AP. AP is nothing but y1 into QP. QP is nothing but the distance between both of these. This is nothing but x1 minus x2. So this is x1 minus of x2. Further, plus of half, we have AP. AP is nothing but y1 plus of CR. CR is nothing but y3. And we have PR, the distance between both of them. So this is nothing but x3 minus of x1. Further we have minus of BQ. What is BQ? BQ is nothing but y2. So this is y2 plus of CR. CR is nothing but y3 into QR. So as we can see, we have QR means a portion from here till here. So as we have, this whole portion is nothing but x3, this portion is nothing but x2, this whole portion is nothing but x2. So this would be nothing but x3 minus of x2. We can write it as x3 minus of x2. As you can see, we have OR total is x3, OQ total is nothing but x2. So this portion QR would be x3 minus of x2. So I'm writing it over here that this is nothing but x3 minus of x2, x3 minus of x2. So let's just sort it out, all the values that we have over here. So we can write it as nothing but half and half we have. So we can take half common out of all these. So we have half common out of all these. So we can write it as nothing but we can write it as y2 plus of y1 we have. Further we have x1 minus of x2. Further plus of y1 plus of y3. Further we have x3 minus of x1. We have minus of y2 plus of y3. Further we have x3 minus of x2. So we have all these values over here. So let us suppose if I am expanding it further and I am multiplying the values of x1, x2 and all of these terms. So we will get the elements as nothing but, let us suppose if I am multiplying all these terms, as we can see there is nothing common in between all these. So it means we can multiply all the terms together. So let us suppose if I am multiplying it. So this is nothing but y2 of x1 minus of x2 plus of y1 x1 minus of x2. Further we can multiply it as y1 x3 minus of x1 plus of y3 x3 minus of x1. Further we have minus of y2 x3 minus of x2. Further we have minus of y3 which is x3 minus of x2. So let's just again multiply all these terms. So we have y2 x1 minus y2 x2 plus y1 x1 minus y1 x2 plus of y1 x3 minus y1 x1 plus of y3 x3 minus y3 x1 minus y2 x3 plus of y2 x2. Further we have minus of y3 x3 plus of y3 x2. So let's just cancel out all the values that are cancelling with each other. So let's just look out for the elements that are cancelling with each other. First of all we have y2 x1. So let's just look at if we have y2 x1 anywhere over here. As we can see we have minus of y3 x3, we have y3 x3. So these values are getting cancelled with each other. And furthermore we have x1 y1 and we have x1 y1 in negative and positive. So both of these values are getting cancelled with each other. Another thing, we have minus y2 x2 and we have y2 x2. Both of these values are getting cancelled with each other. So at the end, what are the values that are left out? The values that are left out is nothing but half of, we have y2 x1. Further we have minus y1 x2. So let us suppose if I am rearranging them in such a way that they do have the coefficient, or we can say they do have x1, x2 or x3 as similar terms. So let us suppose if I am taking y2 x1 and minus y3 x1, because both of these have x1 common. So let us suppose if I am taking this and this all together. So we have y2 x1 minus y3 x1. Further we have the element as minus y1 x2 and we have another x2, that is y3 x2. So let us suppose if I am taking both of these together. So this is nothing but plus of, let us suppose I am writing this first. This is y3 x2 and further minus y1 x2 and further I'm taking the elements that do have x3. So as we can see, we have this y1 x3 and further we have this minus y2 x3. So we can write it as y1 x3 minus of y2 x3. We can write it in this particular formation. So as we can see, we can take the elements x1, x2 and x3 common out of these brackets. Out of these brackets we can take x1, x2 and x3 common. So let us suppose if I am writing it as half of, I am taking x1 common, this is y2 minus y3, plus of, I am taking x2 common, y3 minus of y1, plus of x3, this is y1 minus of y2, and this is nothing but the area of the triangle ABC. This is nothing but the area of the triangle, which is nothing but half of x1 y2 minus of y3 plus of x2 y3 minus of y1 plus of x3 y1 minus of y2. This is nothing but the area of the triangle ABC when the coordinates of the vertices of the triangle are given to us as x1 y1, x2 y2 and x3 y3, and this is nothing but the area of the triangle now, which we will use in order to solve or find the area of the triangle. I hope the derivation related with this particular area of triangle is all clear to you. So hence we have concluded that for any particular triangle whose coordinates of the vertices are given to us as x1 y1, x2 y2, x3 y3, it means we can find the area of the triangle using the formula as nothing but area of the triangle ABC is nothing but is equal to, so the area of the triangle, this is nothing but the area of the triangle ABC is nothing but is equal to half into x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus of y2, where x1 y1, x2 y2, x3 y3, they are nothing but the vertices of a triangle. So always remember that for any particular triangle whose coordinates are given or whose coordinates of the vertices are given to us as x1 y1, x2 y2, x3 y3, then for that particular triangle we can find the area using the formula as half of x1 y2 minus y3 plus of x2 y3 minus of y1 plus of x3 y1 minus of y2. Now let's just use this particular formula to find some of the questions that are based on the area of the triangle.